Welcome to Wickerson Studios. I'm continuing with this Ghpython course, looking into Rhino common as best I can from Rhino script syntax. We've moved from points 110 to vectors at 112 or 002, and we'll have a look at it. It's a Grasshopper script that basically runs. We'll take off everything except for the vector visualization, and we have a script here that we can double click, and you should be in the habit of being able to set inputs and set their types. And this one happens to be a float all the way through. And I'm going to turn off everything except for our vectors of what we're actually visualizing. This is the one we're visualizing right now, zoomed in. And I'm able to change that vector. And I'm also actually able to record the length of that vector. And what I use is two functions here, rhino.geometry.3d and XYZ being my parameters. That's a simple thing to hard code. If I wanted to do vector 2 and hard code that, you start with the Rhino dot system, go to geometry, tab it over, go to vector 3D, tab it over, and then you can hard code that at 2, 4, 6, and you would have a nice little vector there that could be outputted to, if you wanted to, b equals vector 2, and if we hit do that, and then we come in here and we change this vector 2 back to b, we should be able to run the script and have a visualization on the second vector. So there's the first one and there's the second one. Keep in mind that the first one is the only one that's parametric, telling me the length, and I can find the length of the other one, but it's pretty static. So if I just grab b and plug it into there, you'd see well, there's the vector itself. It doesn't tell me the length because I didn't write that into the script. I'd have to change that and change the vector b, vector 2, and that should be able to do it if I run it. And there we go, we have the length of the other vector if we want that. But I'm quite happy having my parametric vector because that makes it a little more exciting. So nice little script to begin with to get you thinking vectors. Okay, let's go down into the next one. And as we go, I think what I'll do is I'll take these ones and disable. And we'll go into the next one, and once again, take everything and make it not visible. Take the preview, and you'll see we have a little unit vector here. And what happened with that was, as we visualize, and I'll use this to see the vectors, as I run this script, and we'll open it up. Let's take this up here. You can see I imported Rhino, and I'm trying to find a way around building vector lengths, vector unitizing, vector scales, by multiplier. I found different ways of doing this that Rhino script was a little different from Rhino geometry, and I think it did an okay job, except I outputted a lot of booleans as opposed to vectors. So that's kind of interesting to think about. If I take A on, you take a look here and run it, you'll see A is true, which what we're testing is A, is it unitized? And yes, it is. Our original vector was not unitized, so if I took off my unitized here, and took off my take off all my scale and my reverse and run the script, it's going to have a problem because it's trying to output those things. So I have to also take these off. And what I'll do is I'll just comment them all out for now, run the script, and now I'm able to see that I have the original vector, which is here. If I want to unitize it, then I take off my comments and I activate A, which is the unitized vector, and the vector will change to the unitized shape, which is there. Now if I take off the vector scale and the multiplier, which is parametric, and I run that again, I'll be able to scale that by multiply. So I should be able to get my XYZ, radians is the turn. Let me try that again. Scale should be running from my multi-factor. And what do I have to do? Oh, I have to put in, I think I have to put in B. Hang on. There we go. I've got a scaling factor that should be having a play here. There we go. Scaling that vector initially. I'm not scaling the unitized vector. And then if I wanted to have my reverse vector on, I would have to take my C and go to my C and see what the reverse vector is. And there, here we go. B, reverse, and test it. And I should, hang on. Oh, it's a true false. It's not giving me a vector. It's just saying, yes, it was reversed or it wasn't. So I have to go back to my original. And now I've actually reversed my unitized vector. So it gets confusing when you write too many of these scripts in here, but it's really something to look at. Try and find a way around and find out so you can start making an adjustment from the vector length, vector unitize, vector scale, vector reverse, and vector rotate in RS, because that's pretty simple to grab the functions and use those. But when you get into this kind of Rhino comment, it gets very complex, and you'll see where it kind of breaks down as I talk a little farther into this. And I've hit my own walls, so I've actually started to point towards, should I be learning C? And we'll see that in the end. So let's run the vector with the radians, changing the angle, and there you go. Now I have control over that vector again, because I've applied all of these things to it. So you've got a unitize, you've got a scale, and you've got this rotate, which you can have them through many pi's. So I can go from there all the way around almost twice. So that's enough to start and think about. It changes things up, and it's really trying to translate that original RS RS script into Rhino comments. Sorry, I was just looking over at a message. Okay, so if we go into vector function, look at cross product, subtract cross product and angle. Let's take a look here. Sorry, and we'll grab that, bring it down here. And what's interesting, and let's take off this one, deactivate it, disable. And what do we have here? We've got a bunch of vectors on display, so we'll take this off. And we'll take a look at these little vectors as they go, and they can be pretty fun. So these two, as I generate them, and I'm generating all these other ones, let's run the script. And what I have is, initially I built a vector XYZ, and then I actually just added, hard-coded in, and added points. So I have a vector A and a vector B that are created, two vectors, and they can be seen if I want to go into here. There they are. That makes a little more sense to jump over here. And you can see I moved them in the XYZ. So I can start them at 0, 0, 0. But it doesn't make for a very visible script because it's kind of not off of the world plane. So let's get started with these two vectors here, which happen to be vector A and vector B. And we can look at them separately if you want, the 1 and the 2. But what I'm going to do in this script is I'm going to add the vectors together by going to Rhino Geometry, Vector 3D, Add, and then put the two vectors together and end up with this one. So that's the together. That's what's added when you do it. If I do the subtract, I'm going to get this one, which is subtracting vector B from vector A. And you could change that and subtract vector A from vector B, which can be fun. And so you start thinking vectors and you start visualizing vectors. So there's one minusing the other one. So that makes a little more sense. And then I have the cross product, which really blows up into a long stretch because you're basically cross product those two. And when you end up using that, you get a much longer one coming off of the, you'll see it's related to the normal, plain normal. And that's another one that I've been playing around with, trying to move away from, I believe, if I could just find it here for a second, getting into a little bit of the maths that are associated with that, and that would have been, yeah, looking at the vector add, vector subtract, vector cross product, and vector angle, which are all the Rhino script functions that come with it. So I'm still doing well translating these in Rhino geometry, and I'm just kind of moving right along. So let's keep going. And now moving an object by vector seems to be where I slowed down and hit some walls that you'd think would be a very easy script. Well, let's just jump in there, and I made it a very easy script. It took me a long time to make it easy, because I was looking at these older scripts in Rhino, basically going in, writing points, list, empty, adding points, X, Y, Z, which I can change and play with. And you can see here, this really causes another point to kind of have another starting point from what's happening. Best to just leave it at 0, 0, 0 for where I'm at right now, not on the X, Y, Z. And that's just a starting. I don't think it actually comes into play here, except that's my beginning. And then I made a vector 3D that moves in the Z 1 point. And I hard-coded that. And I could have changed that, but I'm okay with what's there. And then for I in range N, I can actually move that point as many times as I want. So it's a nice little script. Hard to wrap your head around it, really, what's happening. At least for me, I'm multiplying the vector by I, and then I'm able to output those points. So it was a way in getting around to make a series of points that grow out of themselves. And really, it doesn't really matter at this point if they're all in X, Y, Z or not, because that's not really going to change. That's just the starting point that I was using. But I actually ended up building a vector that didn't really matter anyhow. It was a unit vector moving out in the X. So as I run that, I really just need this half. I have to wonder how much of this I actually need. And I'm just going to start deleting things and see if it has any function on it. This one obviously would have a major effect because I've lost my list. But the point of Rhino geometry is really non-essential to it. So I'm just appending points. And that's what you do. You write a script, got to wrap your head around it, and then you try and get it so you can visualize what's happening. So we'll keep moving on, and that was just kind of a little move factor that I'm building my own kind of Rhino geometry, not dependent on Rhino script syntax. So as I go, and I'm supposed to be taking these disabling off, going down to the next one, this could be interesting because I went back into the same script and I added some things. I added a degree to a curve. I decided to make NURBS curves so I can change them from polyline to 2, 3, 4, and 5 degree curves, which I thought was nice. I could also change how far out I go. And then at this point, I could change, have a major effect on the XYZ, which I think is pretty interesting. So that's just a little bit of geometric control over a very interesting curve. And the script of that is right here. I'll bring that down, and I keep making the same mistake every time. And you'll see what I did here. I wasn't going off if they add polyline. I was actually going into the Rhino geometry, so I'm still doing well to stay away from Rhino script syntax, which is going to break down soon enough because as the functions get more and more complex, I can't write them in Rhino Common, so I have to start using the Rhino script syntax. And we're going to go through this whole text and keep trying to translate this information. So here I made a point list. I did generate that point XYZ, and I did use that very similar to the early script, and I penned that points list with points. I made one vector here and one vector here, which actually is very playful, just playing on the shift, the one going out in the X direction by 2 and one going out in the Y direction by 2. You could change that with a Z and do whatever you want, really gain control of these curves. And then I do an iteration of step, 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 step. So new point and new point keep being generated by going by vector 1 and vector 2. So we're going using vector 1, then vector 2, then vector 1, then vector 2, and we keep iterating that through I. And then I created a NURBS curve, rhino.geometry.NURBS curve, create, and you'll need to know if it's open or closed. So if I chose true, this is going to close up on us, and you'll see it just loops back to itself, which is kind of a funny form, but it wouldn't be bad to kind of think of that as a comb or a device to surface to maybe flow around another curve. So maybe I'll leave that on true. The degree can change once again from NURBS 3 to NURBS 5. You get quite different shapes as you go, which is a very nice tool. And then the points you're iterating are simply the points that are coming out of your function, your iteration. So hopefully that makes a little bit of sense. And I've generated all these nice things over here to kind of keep an eye on what's going on. Okay, let's kill that one and disable. And let's go on to the next one. And we don't have too many more to go to on here, but what I did was I looked at the original Rhino script syntax move. And I pulled this from the Rhino.common website, and all I did was change. I have to select the curve to move, and this is very dependent on a closed curve. And when you click it, you can only move it as I run the script and I click that curve. It will only allow me to move it constrained to the Z axis, up or down. So if I run it again, I grab that curve and I go down. Excuse me. You can see that script was written in very specific to finding one and selecting one. All I do is change the script context doc over to Rhino doc.activedoc.objects, and that allows me to play with this in the Grasshopper node and over to it. So I kind of had the original one, and I was like, okay, how can I translate that working script over to this one? And here's what I ended up doing. I'm locked into a function, so I can't move. That's one thing that tricked me out before. If you're stuck in one of these, and I just crashed it because I closed it out while I was supposed to do it. Just ignore that little bomb there. I know it's hard to ignore a bomb, but that is a bomb. So this is an interesting little script that I went in and I generated this form. And this is a very, I like this shape. And I'm actually in the end, after generating the NURBS curve, thought I'd just take that curve and throw it through a circle with different radius that I can change. So when I take it to the flow, or sweep 1 is what I actually ended up making it follow that rail. You get this interesting geometry. And the only reason I did that was for visualization purposes. It's not that essential. Let's go here and just forget what I did after that curve. And here's the script itself, very similar to what I did. However, I had to go in and make a, I used the random function, which is kind of interesting, as you can see. Use a random function to go in, and I set my x to negative x and positive x as I play through this, so I can keep it tight to the center, and I can keep it wild, and I can keep it tight to the y, and go wild in the same way. And actually, I didn't have my y hooked up now because I was happy with it being uniform in the x and y. See there, you can control your y's, you can control your z's, and I'll show you exactly what happens when you run this like this and throw that through a very interesting animation. I'll just show you this quickly. Animate through. You'll see that it gets real tight and then it gets real wild. So it kind of controls itself but stays constant in the Z. And you can shrink the Z down and the points would change immediately. I have a number of count that's going through 30, but I could definitely have control over that and limit that down to what it was as a curve. And we don't really need these other ones here. Nice little tool for 30. And then I have the degree 5 curve. I can go down to 3 and I can go down to polyline if I really wanted to keep that. So nice control of geometry off of this. Still using Rhino dot geometries only, or Rhino common, and I'm feeling good about that as well. And I'm starting to visualize and do a little bit of work that's easier for me to do in Grasshopper afterwards than actually script it. But this is all a learning curve. Like I said, you research, you develop, you're creative, and then you redo that. I think we're good on that. Fun little exercise with all of those. If I take them all and make them all enable, turn them all on preview on, you start to get a sense of what's happening. And I'm much more excited about a Nerdist curve that's degree 3 to 5. And once again, we're locked into this. Going to throw another bomb because I was locked into it. And let's just go out of here and get all the shapes again and have fun with that. What I am going to do is take another section after all this is kind of said and working. I'm going to go into my attractor points now. And you'll see as things become more and more complex, let's disable this. And let's grab that, move it over here because I want to move on the vectors and attractors. Green is always working. So if I jumped in here and I had these strange points being generated and I gave myself a little point attractor and say I moved it up and I didn't mean to, I should have internalized it. Let's just set one point here and let's set, we could set one point to the same one here. Now you get a very interesting thing happening. I'll show you the Rhino geometry as I'm playing with on the next video. So we'll just disable that one. This one's fairly interesting because, and once again, this one's the most interesting. Go in here and set that. Now you're starting to see, as I get the attractor points working, disabling. What I've done is, as I've written the script, I've gone and written it in green where it works fine in RhinoScript Kintext, which is taken from just an online source, which is easy. But then I've tried, in the best of my ability, enable to basically start to think about how I would write it or transition it into Rhino geometry. And I don't always, I'm not successful because I don't know how to script that well in Rhino Common. So it's this learning curve that I'm on right now that I'm saying maybe I should just go over to C because it's so hard to think about how to build these independent little functions. Luckily, I managed to get, let me just show you this, which is kind of fun. I should have brought it in here, but if I go here and open and I go into this inspect, somebody sent me this really cool tool, which is very nice. You can go in and write definition, split rep, whatever you write in there. The script itself here is beautiful. The simple little script here of import Rhino script syntax as RS, inspect, and then inspect get source, and then whatever you want to take a look at, it will generate the code that might help me go a little better into writing Rhino Common. And I'm getting that on the forums. So things are getting deep. Things are getting really based in research. I can't really just sit here and show everything, and then import libraries weren't being shown, but you can see the import libraries that are necessary for starting to do this stuff. And it gets deeper and deeper, and you're going to want to save things as you use them, try and understand where things are. But I do like this because I can take these two off, disable, and you see I've got a really cool pattern and a tool down here that if I grab all these off, preview off, and only go to the curves, really nice shapes and forms that you have a beautiful script coming out of here, still based on Rhino script syntax with a little bit of Rhino geometry as I can use it, but without going in and trying to write those other scripts. I think it's probably best that I go here and I grab these two and I hit copy and I take this wherever I go now. So I'm going to come down here and I'm going to hit paste, and hopefully those jump in here somewhere. There they are. I'm going to just have to take these wherever I go with Rhino script in a sense of trying to figure out, okay, what am I using? Can I grab that inspect geometry down here, use that simple code, and hopefully you're starting to understand the complexities of this and what I'm racking my brain for, because as I go down here and try and dig into this script, which happens to be in Rhino Python, in Rhino script, I'm going to want to use this script to start seeing how those are made so I can then convert them over because they are really amazing to sit here and have access to these points, move them around, and have these nice control points, and then have this really nice ability to play off of them, rotate them, have a degree angle that has a power to draw it up. You can also play with the degree of the curves, which make it more interesting from polyline to G5. And then you can also just play with your size and script your geometries. Very nice stuff. And as you bring that down, you can see it has an effect. It actually has an effect below, above. But what an incredible tool that if I was to take these curves, and with any luck, I've had trouble pulling out Python nodes and sending them the pipe. I'm just going to try. And there they go. They worked. So very nice little grass forms. And I'm just going to throw a little cap of 2 on it because I'm a sucker for the end caps, closing up reps. There you go. You got a nice little wiggly worm that if you start playing with this, takes a little bit of script time, 153 milliseconds to work, but I can pull that over here, and all that grass and wonder has to kind of adhere to what I want to do. Very nice script. And that's coming out of that Chinese textbook, but I'm trying not to show any of the Rhino script texts directly, not to give their intellectual property up to everybody for free. Get the book if you want to look at those things, but my challenge is getting in here and trying to convert this script over to Rhino Common. And I'll get better at it, or I'll just move into C# and never come out of my room again. Thanks very much for watching. 21 minutes.